Hey guys, welcome back. In this lesson, we're going to talk about collections and primarily lists and arrays and dictionaries, which are a very powerful part of Kotlin language. Also, they are a very important aspect of programming. These are basically ways for us to put objects of the same type into one variable. And you will see why this is very, very important in just a few minutes. Collections are something that's going to stay with you forever. For as long as you're programming, you kind of need at least arrays and dictionaries. So let's go ahead and get started with that. For this lesson, I'm going to go to play.kotlinlang because simply I want you guys to get used to here a little bit as well. You feel free to do it wherever it's more easier for you. If you want to do it in Android Studio, do that by all means. If you want to do it here, that's also a great idea. So here in my play.kotlin what I'm going to do is I'm first going to make an array. I'm going to say I have a variable. This variable is called numbers. And let's say in my numbers, I have something called array of, and the array of goes like this: 1, 2, 3, 4, and 5. So what is this thing? What's the difference between writing this variable and writing a variable that we had before, such as my int equals 1, for instance? The difference in here is that when you have variables of the type array, you actually can access them by their index. The index basically refers to the number where they are in the array, and they begin from 0. So let me change these numbers to some random numbers so they are not so easily readable. So let's say the numbers are like this. Each of them is a random value in here for whatever reason. And then the indexes for them are basically like this. This is the first one, which we call it 0. This is the next one, which is basically the first one, basically. This is 2, this is 3, and this last one is going to be 4. And if I want to get access to any of them, I could basically go ahead and say in here, not like that. I could basically go ahead and say print, and in the print, I could go ahead and say print numbers. And in the numbers, I could actually get the index of the one that I want to print. Let's say I want to print 2. And I'm going to go ahead and play this and run it to see what we're going to basically get. And it says the second item, the 0th, the first, and the second. It says the second item is 345. So basically we managed to put so many items of the same type inside one array, and we can access them by their indexes. Just keep in mind the indexes always start from 0. Now, just like what we had with other variables, the array type automatically infers its type from its values. For instance, in this case, it detected that the values are integers. If I go ahead and say var, let's say animals, and in the animals, I'm going to say it is an array of. And then in the array of, I have dogs, and I have cats, and I have, let's say, horses. Now it automatically detects that the animals is meant to be of the type strings because the values inside it are of the type strings, and so on and so forth. You could do the same thing. In Kotlin in particular, you can actually have arrays that they have mixed type of values. So it doesn't have to always be all of them integer or all of them strings. But that's usually not a very common practice for the most part. Now, I want to show you a few things we can do in here. For instance, I could go ahead and say animals, and then from the animals, I could actually get the first. This way, you can actually find the very first value in an array. You can do the same thing with last, which basically gives you the very last object of an array, and then you can either print that or put it into a value or do whatever you want to be doing with it. The other thing is obviously using the subscript that we just saw, which is animals, for instance, number 2. That's going to give you, how many of them. It's going to tell you what is the object in the second location, which in this case is going to be the horses. Or you could do things such as animals.count. That's going to tell you how many objects are there in that array. A lot of times you want to know how many of them are there for whatever reason. Now, these are all called arrays, and the reason that we use these kind of arrays is because they are the simplest type of making a collection. However, these are not the most flexible ones, simply because once you set it to be with 3 objects at the very beginning, when you're initializing the animals, you cannot change that. And that's not really a good thing, because what if I wanted to add one more animal to this group of animals? For that kind of things, we actually use another type of object, which is called a list. So in here, I'm actually going to go ahead and say val, and this is going to be a mutable list of, and then in my mutable list of, if it allows me to autocomplete, I could actually add all of those values. I could say dogs, and I'm going to actually add only cats. And then what I could do, okay, in here I missed something, animal list. And then what I could do is this, I could say animals list, then I can say dot add, and in the add I can actually go ahead and add a new value to it. I could say I want to add horses. So as a rule of thumb, for the most part, for almost everything, as long as you don't face a particular situation, you can stick to lists for everything instead of making arrays. Arrays are the definition of what's going on. Lists are a little bit more of a flexible way of doing that thing. For instance, here I could just go ahead and say add something. I could go ahead and say animals list dot remove, and in the remove I can actually use one of the 2 technologies. I can, or one of the 2 functions. They are kind of technology, but one of the 2 functions. I could either remove it by the actual name, say remove the dogs, or I could say animals list dot remove at, and I could say what I want to remove is I want to remove the object that is at location 0 right now. So I want to remove this one, even though right now that won't be the case. Right now we have the animal list, which is dogs, cats, and then it becomes dogs, cats, and horses. Then dogs is removed. So by this line, the array is actually cats and horses. If you want, we can actually try to print that. We could go ahead and say print whatever you find in the animals list, basically. So let's go ahead and run this application, see what it's gonna do for us. Or we actually only have the horses for some reason. Let's see, what did we do? Oh yeah, absolutely. So we removed the dogs. So dogs, cats, and horses became cats and horses. Then we removed the 0th one. Let me print all of these at all levels so we can clearly see what happens. Let's print it once after the horses. Let's print it once after the removal of the dogs, and let's print it once at the removal of the 0th element. Let's see, what do we get in here. The very first time we are printing the animals list is here. In here we should have dogs, cats, and horses, and that's what we have, dogs, cats, and horses. Then we remove the dogs, so we have cats and horses, and then we remove the 0th element, which is this guy is gone, and we only have the horses the last time that we print. I could actually change these guys to print lns, so we can see them on a new line, so we don't have to see them like this next to each other. So let's run it one more time so we can see them on their own specific lines. So that makes it a little bit easier to read. So that's how we use arrays and lists, and how do we get to add objects to them, and how do we get to remove objects from them. Finally, in this lesson, I should show you how do we use another thing, which is called a hash map. So I'm going to get myself a little bit more space in here. A hash map is basically a dictionary. What a dictionary is you have a key and you have a value for it. You're searching for a certain word and it gives you a certain definition for it. You're searching for a certain value, and for that value you can find what are the relevant terms that they correlate to that. That's exactly the definition of using a hash map or a dictionary. So I'm going to go in here and say value. I'm going to call it my map. And my map is going to be this. It's going to be a hash map of, and in the hash map of, I'm actually going to have to write the values that I want to have in here. In the hash map of, I want to have these values, for instance, and M should be capital, I guess, hash map of, and I want to go ahead and say Vancouver, and I'm going to connect that to Canada. And then I'm going to go ahead and say I have another value that is going to be San Fran, and that is going to be related to US. So the way it works is basically makes this combination of keys and values that they are paired. That's why they call it a key value paired system. Each key is paired to a certain value. So if you're searching for a certain number or a certain value, you can actually search for the key of that and find the value of it, which makes it very, very useful in many situations. So for instance, you can actually search by a certain value. You can say my map, and then in my map you can actually say give me the my map value for say Vancouver, but this is actually setting the value of my map Vancouver. I could actually say this one now becomes a new value, but that's not what I want to do. I want to say my map actually dot get value, and the value that I want to get is for this number, for this particular term for Vancouver. So I could say my map dot get value for Vancouver, and it's going to give us this one country, which in this case is Canada. So I'm going to say let's put that one in val country to be that. So it's going to get the value for that one. We could add new stuff to it, or we could reassign stuff. So for instance, I could say my map. I'm going to go ahead and say my map, let's say New Mexico. That's as much as I understand about geography. Don't question me about that. Mexico becomes the value for New Mexico. You could of course remove stuff. You could say my map dot remove, and in the remove I'm gonna say what am I gonna trying to remove. I'm trying to remove San Fran. So if I put that in there, it's going to automatically detect that I'm trying to remove the key. It's giving me an error. Let me see what the error actually is. Let's say remove key. Yes, but it should be automatic. It shouldn't be asking me to enter the key. So remove, and in the remove is going to say, yeah, there was no error. For some reason it gave me an error before, but then it disappeared. This sometimes happens with compilers. It's not such a big deal. So these are the different ways that we use a map. What I would really suggest for you guys to do as a quick exercise is that earlier on I asked you to write different attributes about yourselves using simple primitive values such as integers or floats or whatnot. This time I'm actually asking you to write it inside a map, because this is basically what you usually do when you're programming for real pieces of code. You actually write different objects into different dictionaries. So you can have a dictionary which is for your user. I'm going to write the beginning of it and I'm going to leave the rest of it to you guys. I'm going to say, let's say my user map, and the user map is going to be a hash map of, and the hash map is going to have a name. So that name basically relates in this case for me to that. And then I'm going to go ahead and say this user actually has an email, that the email is going to be the email of this user, for instance. If I can type everything properly, not usually, I think you already figured it out. The next thing is, let's say this user is, let's say has a role. That role is going to be a teacher, so on and so forth. You can actually add everything about your user into one dictionary, and then it becomes a lot easier to search for it. So for instance, if I want to find my user, what's the role of my user, I can say val role, let's say role is, it becomes my user map dot get value of role. And now I can actually find the value of the role for this user and place it inside something for myself. So give it a try, add all of those things, and then once you're good, let's move on to our next lesson, where we bring everything we learned in this section into one program that's actually going to do something for us.